Hi, everyone. There's so many people. I better not fuck this up. But yeah, welcome to this talk, Unveiling the Ivanti vulnerability. My name is Sina, Sinology. My English is not very good. I try to not make grammar mistakes, but forgive me if that happened. Why are we here? First, let's answer that. We're here because I reported a vulnerability to Zero-Day Initiative on a product called Ivanti Endpoint Manager. It's basically, we'll talk about the product, what it is, but it manages some endpoints in your enterprise. With this vulnerability, you could compromise the main component, which is the Ivanti Endpoint Manager server. And then this was assigned a CVSS 9.8, and sometimes it was also assigned a CVSS 10. Before I do anything or talk anything further, now that we know why we're here, I just want to give a few shout-outs to three of the people who were very important in me learning about .NET and .NET exploitation. Most of the topics that you're going to be seeing in this slide. First is James Forshaw, great guy. He has done a lot in .NET exploitation, .NET rerouting, and all of that stuff. Second guy is Surush Dalili, one of my mentors. Great guy, very knowledgeable, has done a lot in the .NET scene and .NET exploitation. And lastly, I can't really pronounce his last name. I think it's Marcus Wolftange, if I'm not wrong. A member of the CodeWire team, has been always answering my questions regarding .NET vulnerabilities. Yeah, I just, when I reported this vulnerability, it was like 130 days ago, and then Ivanti took its time to actually disclose the report, and then ZDA was pushing them to disclose it very soon, but it was taking a lot of time. But this got a lot of good attention. And then just a few days ago, Ivanti published a security advisory for their Endpoint Manager software. Endpoint Manager has two versions, as far as I know, 2022 and 2024. That doesn't mean that 2022 was just like it doesn't update it or anything. It doesn't get updated or anything. It's just like Windows Server 2022, stuff like that. It just has two versions. And then there was a ton of CVs. This product is very, very vulnerable and heavily deployed as well. But only one of these CVs was something that was pre-authenticated remote code execution, at least known publicly. And it was this one, the one that I reported. The description says that what they publish, the serialization of untrusted data in the agent portal of Ivanti EPM before the update, software update number 6, or the 2024 September edition, allows a remote, unauthenticated attacker to achieve remote code execution. That sounds very scary. And now let's talk about who I am. I'm a vulnerability researcher. I'm a Pwn2 contester. I blog at Summoning Team, and you can find me at Sinology. Now, let's talk more about Ivanti EPM. It's one of those fancy-looking softwares that a vendor sells to a lot of people, and it's not very well tested. It has a ton of vulnerabilities, public and private. If you just do a quick Google on what is Ivanti, they say it's an all-in-one endpoint management. I think it also does endpoint protection as well. Like it has like agents and antiviruses as well. But you can install software, push updates, do statistics checks on your endpoints. Like you have like a Active Directory environment, and then you want to manage all the machines that you have. It has won a lot of awards. This is just to add how important this product is. And then none of these awards look very good in regards to security-wise, unfortunately. While I was reviewing the attack surface for Ivanti EPM, I noticed that there's a lot to cover from basically native web services, custom web servers, .NET stuff, .NET rerouting, a lot of ASPX applications, a lot of IIS application pools, you name it, everything was there. And what I was, I think, what? 1, 2, 3, 4. Can you hear me? That's good. Okay. What I was looking for was the. Okay. 1, 2, OK, now it's fixed. Yeah, it's fixed now. OK, thank you. Thank you very much, guys. Appreciate it. While I was reviewing Ivanti EPM, there was a lot of attack surface, but I was looking for something. Either I could bypass the authentication, or it was unauthenticated by its nature, so like a pre-auth RC, something proper, that I could go brag about, and then I could just get a free flight ticket and stuff and show up here, and then give the stock. So this is what I went for. The vulnerability, by its nature, like the coding style, it's just 2, 3 lines of code. It's very simple. The first line, a TCP channel gets instantiated. The TCP channel is part of .NET framework by itself, and the argument 0 is passed to it. And then the channel is, after it's getting instantiated, it gets registered, and then the first argument is the channel object that was instantiated one line before, and then the second argument is a false value, false Boolean value, which sets the secure flag to false. And then lastly, this channel will register a well-known service type of Landes agent portal, iAgent portal, and then expose it under the object URI LDSM. That was a lot of buzzwords. I know that's why we're here. Everything that I just said, we're going to cover it, what it is, and why is it important here. But before we go any further, I just want to say the flag that you just saw, according to .NET remoting documentation, when the secure flag is set during TCP channel registration, your communication will be secure. But secure, as it doesn't mean secure against attackers, it's just secure against like integrity of the communication. We'll get to that. Everything I know about .NET remoting exploitation, which is the topic of this talk, is based on James Forshaw's whole research about this topic. He published a lot of papers and a lot of blog posts about this back in the day, but it's still to this day, even though Microsoft says don't use .NET remoting, it's being used heavily. Now let's talk about what .NET remoting is. Simply put, basically .NET remoting, like if you use Corba or like the RPC stuff, or remote method invocation in Java, this is just equivalent of the same thing in .NET. You want to invoke methods remotely on a separate app domain or a separate process, either on the same process or a remote machine, or a process on the same machine, or even one process do it to itself. For some reason, you don't want to use simpler ways, you can use .NET remoting. Basically, it has 2 important things, a method call and a method response. Like any other RPC, you're remotely invoking procedures. Those procedures will have responses, and you're making calls to them. And then parameters passed to these methods, which are remotely also serialized. For example, you call do something, and then you pass the arguments to it. The return value, or if an exception happens, is also counted as a response. Let's see it what I just all that buzzword said, how does it look like? We have a client, we have a server. The client and the server will communicate over a specific channel. This channel can be of type TCP, HTTP, IPC. HTTP is basically also TCP, but for some reason, in .NET terms, when you use TCP and HTTP, they're 2 different things, because they're transmitted a little bit differently, a lot more differently. The server will register a service. The service is the application, is the method, is the interface, is the class that it wants to expose to be called by other people. So it will expose it under a specific URI. The URI starting specifies the protocol type, the channel type. So as you can see, we have TCP, HTTP, IPC, but in this case, it's using TCP. It says, I want to expose the service under a TCP protocol on all the interfaces for port 1237. And I want to expose this service under the URI, under the object URI my service. Then a client can call into this remotely using all the magic in .NET remoting, and then send a packet that looks something like this. Now, if you have an eagle eye, you will catch that this is a serialized object being transmitted, and serialization most of the time leads to bad behavior. So the client will serialize this packet, send it across, it gets received, and then deserialized. And then what can go wrong? These serialized messages can be transferred over default channels, such as HTTP, TCP, or IPC, but you can also implement your own custom channels. I've seen that in the wild, not that much, but you can see them in very well-known products, actually. The transmitted information, as I said, it's serialized, also known as formatted in .NET terms. If you go look into the implementation of a DLL called system.runtime.remoting, you'll notice that it's very simple. There is just a couple of classes, which their name just says this is for the IPC, HTTP, or TCP, and the sinks and everything else, which we'll talk about a little bit further. The whole dangerous thing with .NET remoting is the fact that it does automatically deserializes all your requests. And this automatic deserialization leads to catastrophic behaviors. Microsoft has always been recommending, and this post you see here is from 2009. It's saying, don't use .NET remoting, use WCF, Windows Communication Foundation, a alternative to .NET remoting that you can remotely, again, invoke procedures and methods. Just don't use .NET remoting. It achieves the same, you can argue with this, but at least 95%, it achieves the exact same functionality, but it's just not as bad as .NET remoting. Now, this might be the first time hearing about .NET remoting. .NET remoting is simple. A server will just write a couple of lines of code. It creates a server listening on a port 1, 2, 3, 4, 5, for example. It registers that it calls it a channel, and then it will expose a class and all of its methods under a certain URI. In this case, that URI is my remoting class. And the class that is getting exposed is called my remoting class again, under the port 1, 2, 3, 4, 5 for the TCP channel type. And then a client will simply say, I want to connect to a remote .NET remoting service under this specific URI, TCP, the IP, the port, and the object URI which was used. Now, James Forshaw has published a diagram of how a overview of the whole .NET remoting scene and how it works. Basically, you have a client and a server. They both have channels. They communicate to each other, and then they use something called a transport sync. Transport sync will pass the message to formatter sync, and this just goes back and forth. The first time that I saw this, I was like, what is this? Like, I don't understand any of this. And I think it's probably because I'm really slow to catch up, but I think it took me like a year or something to understand all the pieces in this picture and then like really dig into them by reverse engineering them. And I saw other people saying they know exactly what this is, but they didn't really have an idea of what this is. So it can be complicated, but we'll try to make it more simpler here. That diagram can even be more messy if you dig into some custom targets, which they try to use the core implementation of .NET remoting, but they want to customize everything. So they can customize the transportation sync, the client channel or the server channel, the formatter sync on both sides, and also the dynamic message syncs. By default, .NET remoting offers 2 deserialization syncs. These deserialization syncs are where your message ends up, basically. You know, sources and sinks, all of that stuff. You send a serialized packet, it ends up in a sink. And that sink's job is to deserialize it and understand that packet. By default, we have binary formatter sync and SOAP formatter sync. And these two are horrible, horrible, horrible .NET deserializers, which basically give you code execution in majority of times. But Microsoft thought, OK, these two, using these two basically formatters or deserializers, binary formatter and SOAP formatter, is very dangerous. How can we do something that protect against just people just nuking the endpoint and just getting code execution? What they did was they introduced a concept called type filtering. Whenever I say type filtering, this is because with .NET remoting and all of these RPC like RMI and Corba, what you're doing, you're transmitting your objects, and objects are called also types or classes. These are all just connected to each other. So they were like, we want to introduce some sort of a mechanism that will control what types are dangerous and what types are not. And a developer can customize it or use the default one. So they introduced filter level. A filter level protects against automatic deserialization using dangerous types. They introduced two modes for this type filtering. One is called low, and one is called full. And this is how it looks like in code. The first line will create a sync instance. Whenever you're creating that deserializer, you can set a setting on the serializer called type filter level. And then if you set it to low, which Microsoft recommends, it will protect against people just exploiting your .NET remoting instance and deserializing whatever they want. And then you just pass that setting when you're creating your TCP channel. What happens when we're exploiting a .NET remoting server, which is using type filter level full, which is not the default one? Well, basically, you can achieve remote code execution. And James Forshaw did an amazing job on covering how exactly this works. As like an overview of it, basically, he realized that he can instantiate a directory info or a file info class instance, and that object will stay on the server side, and then he can access a reference to that object from the client side. So basically, you can do file system operations, as the names will give you, directory info, file info. You can basically do file system operations on the server side, and then write files, read files. But how exactly does that work, does that look like? Well, we have a client and we have a server. They instantiate a remoting channel, and then we have a server which has something called a binary server formatter sync. This is the sync it chose. It could have used SOAP formatter, but it's using binary server formatter that handles .NET remoting messages. The client will instantiate a create directory info, like it creates a directory info. It serializes it and then sends it across. But the problem is, well, if you create a instance of directory info, that object is on our side, like it's working on our file system. We don't want to write a web shell or a DLL into our own file system. We want to do it on the server. So we need to trick the server into instantiating this directory info and passing us a reference back to us so we can use it to control the file system of the server, not the one that we have. And the trick goes over that, which will cover how exactly this reference leaking kind of works. But once we do have a directory info instance that is referenced by object, it's marshaled by reference, we can basically do like a create fake assembly.dll, and that makes the server to create the same file on the server side. But how does the low type filter in exploitation work? When the filter level is set to low, these limitations are applied. Objects derived from marshal by ref object, delegate serialization holder, object ref, envoy info, and sponsor cannot be deserialized. Now you might be wondering why these ones, because James Forshaw is attacking these ones so much that they put it on some sort of a default list that protects against the type filter full mode. Objects which are deserialized must not demand any CAS permission other than serialization formatter. What is CAS? Well, if you're an old school developer, you should remember that we had something called, well, I mean, we do still have it, something called code access security. It's not specific to .NET. You can utilize it anywhere in the Windows environment, but it's mostly used in .NET as well. Basically, it will control what a code does. For example, you want to deserialize a packet, deserialize a message, and then you think maybe somebody, while the code is being deserialized, will pop calculator or creates a process, or it will write to a file system or do a connection back, like a callback or something. So you tell CAS that when this packet is being deserialized, I don't want any kind of file system activities, network activities, or anything being caused by this code. And if it did, just throw an exception and don't do those. That's how this whole code access security works. It restricts untrusted code from privileged actions. Now, how can we bypass CAS? We have something called a permit only in CAS. Basically, in code level, that's how CAS works. You just invoke CAS permit only, and then you tell it that I only want certain things to be permitted. And with .NET remoting, as we said, only, we said it here in this slide in the last line, we said it only allows deserialization permissions. not file system, creating processes, or anything else. How can we bypass it? Well, James Forshaw figured out that this CAS is only applied when you're sending when you're invoking a method remotely. So if we want to send a packet which is of type method call, so you're calling a method remotely, and then you want to send a serialized packet which is malicious and creating a process or something or working with the file system, CAS will prevent you. But for some reason, that God knows why, they don't use CAS when they want to deserialize messages that you're returning to the server. So basically, when you're invoking a method on the server, there is CAS. But if you can somehow make the server to invoke a method on your side, and you want to return a value as the return value of that called method, CAS doesn't apply, and it doesn't enable CAS. So you can get around it that way. But we need to look for a universal way that we can make any .NET remoting instance will call back to us. How can we get a callback now? Well, there is a special class called initialize lifetime server, and it's a great candidate. Basically, this method is implemented on the server side of .NET remoting, and then it manages object's lifetime. So you can instantiate it and get an instance of it from the server. Once you do, it implements an interface called ILEAS. It doesn't matter really what it is for now, but it basically has a method called register that you can call. And once you call it, it makes a call to the server because it's implemented on the server side. And it expects an argument of type ISPonsor. Not exactly of type, but just it needs to implement ISPonsor. And after 10 minutes, the server will call a renewal method that is implemented on your side. So this way, basically, you create an object, and then you tell the server that this object has a lifetime. And there is a code on the server side that checks for the lifetime of the object if it's dead or not. And in order to do so, it calls a method on your side. And it's called renewal. But it takes 10 minutes. So your exploitation will take 10 minutes for the garbage collector to kick in, and then this ISPonsor renewal is called. But that's too much. That's too much time. And here's how it looks like. The client and the server, they make a remoting channel. The client, us, or the attacker, will call the register method, which is implemented on the server side. And after 10 minutes, that's minimum, the server will call the renewal method on the object that we have passed it. And that causes the callback to happen. And once that method calls back to us, we can return a serialized message to it, which will bypass code access security or CAS. But is there a quicker way? Well, Forshaw found out that if you, instead of, in the previous picture, when you're calling the ILEAS register, instead of passing it an argument which implements the ISPonsor interface, so later on the renewal can be called on it, if you pass another object which doesn't implement the ISPonsor interface, the server will think, oh, maybe something went wrong. I'm going to fix this invalid type. I was expecting a certain type, but you've given me another type. So I'm going to try to convert it for you. And it's going to ask us, did the object that you just provided to me have a special method called change type? And if it does have this special method implemented, change type, I'm going to invoke it. Once it does invoke it, it will make a call back to us. We just need to have the object needs to be implementing, the object that we provide to the server just needs to implement the iConvertible interface, and then we implement the toType method on it, which gets called. It gets called by the change type method. And we don't need to wait 10 minutes. This is called argument coercion, coercing the arguments. And this is how it looks like in action. We have a client and a server. We make the remoting channel communication. We call ILEAS register method. The register is that method register method is implemented on the server side. So call goes to the server. The server will receive it, but then looks at it and is like, oh, the argument that you passed to me for the register method that I have is not the type that it should have been. I'm going to fix this and call the change type method that I have on your object, which is going to, at the end, call the toType method. So it's going to make a call to us and then call the toType by the change type. And then we're going to respond to it by another payload that will instantiate a directory info instance, and then it's going to receive it, it's going to instantiate it for us, and then pass us back an instance of the directory info by reference. When we say something is by reference, that means we didn't instantiate it, somebody else did, and then they're passing us the reference to that object. Once we capture it, we can do a write what where anywhere on the file system and achieve code execution that way. Now, until this point, all this, we understand that, OK, so we can do a write what where primitive and then achieve code execution on a .NET remoting instance, even though it's using the low type filter level. But the problem that it happens now is, with Ivanti specifically, I was using it in a certain engagement, and Defender knew how to protect against this because there's like a specific flow that it goes back and forth, and then it was preventing me from writing a DLL and getting it executed. So what I did was I wrote a web shell to one of the IIS INET pub directories, not the INET pub directory, but one of the public web directories that was on Ivanti. But once you do, the code execution that you achieve is running as a IIS worker user. In order to get around that, I realized that the IIS worker that Ivanti has configured has, in the same process, the same worker process, it has access to a lot of tokens. And there's a lot of handles which correspond to tokens that I have privilege to swap with my own token. And one of those tokens belongs to an NT system. This is a flaw in the Ivanti. This is not patched because they didn't really care about patching this one. It's not a, you can't really say it's, they can patch against it, I think. I mean, they can, but they really didn't care about this one. So it's a privilege escalation if you can write to the IIS web application and escalate your privileges. This was inspired by Kourosh Dabbagh. Kourosh Dabbagh is a red teamer, if I'm not wrong. He's a great researcher. He actually has published a web shell for this. I had a web shell privately, but then he published an article about one shell to handle them all. Basically, once you achieve I don't know, you did an arbitrary file upload, you did path traversal, you did a write what where, whatever, with like a .NET remoting or anything, you've achieved to write a file on the server side, and now you can browse to it. But you have low privileges. Now, these low privileges, you can escalate them by swapping your own token for another one in case the application pool has been misconfigured or the web application has misconfigured itself. You might be wondering, how exactly does this happen? Like, how does this misconfiguration look like? I'll give you an example. There's a lot of examples. Imagine you have a web application in .NET, and you've configured it in a way that it does basic authentication. So whenever somebody browses to it, it shows like a 401 unauthorized, and it asks for the username and password. Once you put the username and password, which belong to your maybe Active Directory user or whatever, you log into it, and the application forgets to call the dispose method on the object to destruct the object, so the handle will always stay on that process. And that's one of the problems with Ivanti. And you might be wondering, so does this mean that somebody needs to be logged in into Ivanti, so there is a token there so we can swap it? No, because there is a worker process running somewhere on Ivanti which is always logging into the web application always. So there's always always a lot of tokens just going there, and then you can just swap them. This web shell, once you upload it and you browse to it, you just click Get Token. And then once you do, you can see the list of all the tokens. I don't know if you can zoom here. We can. You can see system, network service, and the iUser. iUser is the one you have usually. And then you can just swap your token and then run a command. We're going to see a demo of that. OK. Sorry. The right corner is a little. OK. Hi. The right corner is a little bit out of focus. Is it possible to focus on it or not? OK. Hopefully, nothing will happen in that corner. But anyways, this is the Ivanti management console. What did we jump to conclusion? This is the Ivanti management console. We refresh, and the directory that we're in right now, the Explorer window in the middle, is one of the folders that is exposed on the IIS application pool. So you basically can browse to it. You can browse to any of these files that are here. You can see the web config, for example, there. You can browse to the web config. I'm just saying this is the directory. We refresh. No file is here. This is the target IP, 163. And then we also, on the left, we have an Explorer window to the C drive, basically the root of the C drive. And we have the exploit. The exploit, it's a custom modified version of the exploit remoting service. We run the exploit. Once we do, it works like a second, so it doesn't take time. That's what's good with these .NET remoting exploits. It's very reliable. And as you can see on the file on the procmon window, we have the agent portal process, which is running as NT system. That's why it's getting highlighted as blue. And even on the far right column, you can see the owner or the user of this activity that just happened. You can see it has invoked a couple of APIs for creating files. And if you look at what file has been created, it's the fake SM file. So we can browse to the file, and then the file has been uploaded there. We click on Get Tokens to get all the tokens which we have access to. And then we can see we have a token for NT system lying around. And we're just going to run a command. We're going to write a pond to C. Since this is running on session 0, if I'm not wrong, you can pop calc. I mean, you can. There is a trick for it, but it's just too much work. Just like you can just write a file to C. It's easier. You can open it, and then the file gets created. Conclusion. Don't use .NET remoting. Use WCF. I've exploited .NET remoting on so many products that are being sold with very crazy prices. Should start a company maybe for that. But anyways, use WCF. .NET remoting is garbage. It's not good. It's a beautiful piece of technology, really. Like when you reverse it and you realize like what kind of decisions they made for like transmitting objects very fast and just like how objects are reconstructed and everything. It's a beautiful piece of technology, but it's just too dangerous to be used compared to something like WCF, or you can use gRPC from Google. Google also has something for that. Even sometimes you can implement a custom deserialization binder for .NET remoting. Even if you do that, what happens is that most of the time can be bypassed. If not public, we have private gadgets for them, just like knock them off. .NET remoting authentication is always implemented horribly. An example was Veeam backup and replication, which we exploited a few weeks ago, which had .NET remoting. It had a binder, and they were using the secure flag. But the authentication was possible to bypass because it was wrongly implemented on the .NET remoting. The binder could be bypassed, and there was like a blacklist that could be bypassed. Shout out to Freitas of CodeWhite, he was the discoverer of that bug. I just did an NDA analysis on it and wrote an exploit. James Forshaw, this guy is just like an amazing human. Like, it's just so much level of knowledge he has. None of this would have been possible without James Forshaw's book. Just read his blogs, readers, and just like read his tools, and then asked him for help, and then just like, yeah, crazy. He has published a book called Windows Security Internals. Go buy it. I've bought it and read it. It's an amazing book. It's really good. I haven't seen any book going over Windows Security Internals better than this book, and as easy to understand as this book. Conclusion, if you have any questions, you can either, I don't know if there's like time for questions. We have, yes. You can ask them here. If you're too shy to ask it here, you can drop me an email at summoning team. I run a training by myself, so I usually do these talks to advertise my own training. It's just a one-man training. It's called Advanced .NET Exploitation. You can just Google it. If you search .NET Exploitation, it will pop up. .NET Exploitation training, and then you're welcome to come to that training if you'd like to. And that's it. Thank you.
So, thank you, Sina. And we have a couple of questions from the audience. So one is, when looking for bugs and vulnerabilities, where do you start looking and why? So, for instance, why the Ivanti device? Why did you choose it?
Oh, yeah, OK. So I've been asked this question a lot of times, like, how do you choose your targets and stuff? Unfortunately, a lot of targets nowadays are protected by paywalls, and you need to like go talk to the sales team and then get it from there, which is very difficult. Or like maybe somebody has it, pull it out of the archive. It's so difficult. But how do you choose those targets? It depends. Like, it's gonna sound crazy, but like what is being targeted now, maybe that's a good one. And then don't get intimidated by it that, oh, I can't find anything on it because everybody is like popping this target. Maybe I'm too late. That's one thing. And then also you can look, like there are some names like Ivanti, I don't know, Ivanti, Palo Alto, and I don't know, like all of these companies. They're pretty famous, right? Just like you can just go Google saying their Ivanti products, and then they just show up, and then just download them and look for vulnerabilities on them. There's another website, like you can also go to, I think there are websites which compare what's the, for example, best endpoint manager software in the market now. And then just like a top 5 list. Just take the top 5 list and then just go reverse it and just find bugs and then just exploit it. It sounds easy to say. It's more tougher to do. But there is no real trick to it. Just Googling what's the most used product. Next one. Thank you. And
there is another one. So the question is, are we assuming that when dealing with hardened.NET remoting, the server must be able to call back to us, Hakka having internet connectivity, or are there any non-OWASP out-of-band techniques which could be used?
OK, I think I got the question. Do you have it in the phone that I can read it myself?
Yes.
Yeah, sorry. Just want to make sure I understood it. Which one is this?
This one.
OK, yeah, you read it perfectly.
Yes.
Yeah, so basically they're saying that, for example, at this step right here, that we're doing the course arguments and then just like makes a callback to us and then we send it stuff. Publicly, you always need to get a callback. I do have 3 private techniques which I use which don't rely on anything callback. It's just a single shot request. It achieves code execution without any callbacks. But publicly right now with the tools we have and the POCs we have, there should always be a callback as far as my knowledge goes. I might be wrong, but that's what I know. Yeah.
Thank you.
Thank you. Thank you. Have a good day.
Thank you.
Thank you.